Okay, so logarithmic differentiation. So what we want to do is we want to take the derivative of y, which equals sine of x raised to the x power. For the sake of people viewing the video, I will do it in more steps than is required on y'all's test. We had a conversation about that in class. So the first thing to do on a problem, this is logarithmic differentiation, so you're going to do a log. So the natural log of y is going to be x. Now natural log of sine of x. Because remember, whenever you take the logarithm, whatever's in the exponent gets pulled out to the front and becomes multiplication. Right? All right, so then we're going to differentiate both sides of this problem. So this would be 1 over y, now dy dx. Okay. All right, so we have to do the product rule on this guy right here. So the derivative of x is just 1, all right, times the natural log of sine x. Now plus x, and this would be 1 divided by sine. And then we say we're going to multiply by the derivative of sine, which is going to be cosine of x. Okay. Now, remember, you're taking the derivative of the natural log of y, so it's forcing y back down to the bottom of the problem. But when you multiply y back through, you're going to substitute back in that sine of x to the x power. So that means that dy dx is going to equal sine of x raised to the x times the natural log of sine of x, right? Now plus x, and now cosine of x divided by sine of x, we can, if y'all want to leave it as cosine divided by sine, I'm not going to count off, but we can simplify that to cotangent. That's the answer to that problem. Okay, this next one, since I'm writing in big marker, I'm going to have to turn this page sideways. Okay, so now we're going to look for this is the thing that we're going to try to find dy dx for. Okay? All right. So, at least for people in my class, other people watching this video, ignore what I'm about to say. You can really write this problem in 2 lines. Okay? For our, well, we're going to do multiple choice, so doesn't really matter. But anyway, you're going to write the problem through 2 lines. Okay? So the first line is just take the logarithm. Show that you understand what the laws of logarithms are. So the natural log of y is going to be 4 times the natural log of sine x plus 4 times the natural log of x to the 5th plus 5 and minus the natural log of tangent of x to the 4th, and then minus the natural log of x divided by 2. Yeah, we're able to put that all up on the screen. Let's see if we can put the next one on. Okay, now remember, whenever you take the derivative of the natural log of y, it's going to be 1 over y dy dx. And so you're always going to multiply back through by the original y that you did. So instead of writing a whole bunch of lines, let's just see if we can squeeze this on as one last answer, one last line that is going to be the answer. Okay, so dy dx will equal, so go back and you look at the original thing that we were trying to differentiate, that's our y. Just go ahead and write y down. Try to squeeze this in here. Okay, that's your original y. So then just put a big parentheses right there. And so at this point of the problem, what we're going to do is, we multiply back through it by what we originally began with. And now I'm going to differentiate each one of those pieces individually. This is the good thing about logarithms, is that once you do a logarithm, it allows you to break your relationship into all these different pieces, and then you differentiate all the pieces individually. Okay? So this first one would be, I'm going to write kind of small so I can fit this on here. The first thing that happens is whatever's on the inside of the logarithm gets forced down to the bottom, and then we multiply by its derivative. Right? Okay. This guy is actually going to be nested in 3 ways. So the first thing to do is to take the derivative of the logarithm. The next thing to do is take the derivative of tangent, which is secant squared of x to the 4th. Okay? And then we have to take the derivative of x to the 4th. Okay, cool. We're going to actually fit all this on here. Minus 1 over 2x. And let's just close that big parentheses that we were dealing with. Yeah, we got it all in there. Okay. And that right there, that is the answer to the problem.